Tell us what you guys do.
When I got to work on Media Tailor, we realized, so Media Tailor is the ad insertion service, personalized ad insertion service. And it's, with ads, things are really, really crucial. Like, you can't lose revenue. Every time you have an outage, you lose revenue. Correctness is also important, and the ad beacon URLs are just incredibly large. And when we were doing, again, this whole notion of you estimate the traffic and then you double it and you double it and you double it, Prime Video used to do the same thing. All right, so when we decide, Talia can attest to that.
I'm like thinking here about like Midas.
That's right. It was codenamed. The project was codenamed Midas. You can imagine why it was called Midas. So we became, with the ad beacon URLs sitting at every quartile, these URLs got really, really long. So we became, we got to a point where DynamoDB just didn't have enough capacity to store and read and write these like tens of kilobytes of objects for the beaconing. So then we decided, okay, well, Dynamo is going to be costing us way too much to do this. It's hard for me to say because I used to run Dynamo, but it was getting ridiculous in terms of the number of IOPS that we needed to pull this off. So we said, okay, well, let's just put it all in Redis. And we suddenly became pretty much the largest customer for Elasticache Redis. And what we realized was Elasticache Redis is a very different experience than just provisioning a DynamoDB table. So when you make a DynamoDB table, you mention it in a sprint plan, or sorry, at a stand-up, you say, I'm going to add another DynamoDB table, and off you go. When you're making an Elasticache Redis cluster, you are, it's a sprint plan because you have to size it. You have to decide the number of shards, replicas, and so forth. And our engineers really wanted that DynamoDB experience for the cache. So what we have built is a serverless caching solution. It's like DynamoDB, but for an in-memory cache. So you just call create cache. You can throw millions of TPS at it. It has a pub subsystem, so you can actually do publish and subscribe. And because it's got a web server built in, you don't actually need a WebSocket layer on top of it. You can do complete device-to-device messaging at millions of viewers without having any web servers in play, and get it out the door in under a day.
Awesome.
Sorry.
Thank you. Thank you very much.
Yeah, just
give me the microphone.
What's the largest object size?
So we are not, the question was, what's the largest object size that Momento supports? So we're not a video origin, just like as contrary to popular belief. So we support up to 5 megabytes today.
Okay.
And we have been getting requests from customers that actually, some customers have come in and noticed that this could be used as a media content origin, but then they need tens of megabytes for the 4K videos. But it's on our roadmap to support larger items. But the niche that we are at is very small objects, like 5 megabytes or lower, where the time to first byte actually matters a lot. Once you get into the 100 megabyte plus, then it's the bandwidth that matters more.
It's a very different scenario.
Yeah.
The second question is, for your pub sub us approach, what are you using for the underlying transport mechanism? Are you using like long polling HTTP? Are you using MQTT? Like, what is the approach? Because pub subs are very, very tricky to do well.
They are very tricky to do well. And a lot of time, people spend more time working on their WebSocket management layer than the actual pub sub system and on the client side. So we start with the client side. We have SDKs in, we support Flutter, iOS, and like Swift, Kotlin for Android, JavaScript, Unity, and so forth. So there's a whole bunch of like client-side hand-stitched SDKs. The transport layer is gRPC, so protobuf on gRPC, which is basically using HTTP behind the scenes. And we can fall back to just polling on vanilla HTTP to get there. We have sequence number baked into the messaging bus. So if you ride the elevator and you got disconnected for a few seconds, you can just pull back and say, hey, I have up until sequence number X. Can you give me this? And if not enough time has transpired, you will actually be able to get back. Or at the very least, you'll know that you missed a few messages that you can use to then trigger a pullback. But we are, the short answer is we're using gRPC behind the scenes for the transport layer.
gRPC isn't a transport layer, it's an interface layer.
Sure. I mean, it's an application layer. So you can say TCP as, as a layer. And on top of that, it's HTTP. And on top of that is gRPC on protobuf.
Sorry, my question was more along like, is it AMQP backed? Is it MQTT backed? Is it WebSocket backed? Or is it long polling HTTP backed?
I think that the closest of those options is the long polling HTTP.
Yes. Okay, perfect,
Yeah.
great. Excellent, thank you very much, I appreciate it. Yeah.
Sorry, I was just still trying to understand the Momento as a product. So you mentioned that it's Redis backed by, like in Amazon, it was like Redis backed by Elastic Cache, right? So right now, and you're trying to like solve the whole like the DynamoDB experience and this thing, right? So your backend in memory is still Amazon Elastic Cache, and you're providing some sort of like a simplified workflow kind of a interface for the customers. Essentially, my question is the backend still Amazon Elastic Cache?
It's not Amazon Elastic Cache. So we're an in-region cache. We don't use Elastic Cache behind the scenes today. We might change to doing it. We have our own set of engines. What we have ended up building to provide the DynamoDB experience is a multi-tenanted fleet, where there's a collection of storage nodes behind the scenes that we peanut butter the data across. And when a request comes in, it comes into our API layer. The API layer it does the authentication, terminates the TLS, and then based on the cache name and the key that you're trying to get, it knows which storage node to go to, grab the data, and send it back to you. But the reason why we do this is because the multi-tenancy actually improves utilization over time, because what we observe, especially in media companies, with the rise of microservices, every microservice ends up getting its own Redis cluster. And when every microservice has its own Redis cluster, then they're all sitting there underutilized. So what we do is we allow companies to share their cache capacity across their microservices, and it's much easier to improve the utilization of the entire shared fleet than it is to manage each individual cluster.
Essentially removing like islands of storage kind of a thing.
Essentially removing the islands of storage, of memory, of networking, and CPU, and we're just trying to put in automation to protect against common outages. So things like hotkey, we have automatic mitigations built in on our API routing layer. Things like heat mitigation, like hot shards, which is something that you have to deal with if you run your own Redis cluster. That's also completely automatically mitigated and becomes our problem. So for Momento, the customers don't have to worry about the number of shards and replicas and multi-AZ and authentication, all that. That's all baked in. And then we just offer this under a seamless interface called just create cache. And you just start doing a million TPS, and we just absorb it behind the scenes.
Okay, so that's one of the pain points of Elastic Cache in general. I've not used it, so I'm just...
Yeah, it is one of the pain points. And it's certainly something you can solve, and my team solved it. Like, Elastic Cache is a great service. Like, I'm not here to say Elastic Cache is bad by any means. We're just providing a slightly different service that's, it's a higher layer of abstraction, and it has the web server built into it, which is something that the Elastic Cache team does not. Like, you wouldn't connect your mobile device to Elastic Cache directly. You would have a WebSocket layer or a web server layer in the middle, and we're trying to collapse all that into one box.